Okay, so in the previous video, I talked about the general process of getting OSPFv3 up and going. Step one, you do basic IPv4. Actually, step 0 is you do basic IPv6 configuration. Step 2 is you create the routing process. Step 3 is you create a router ID. This is assuming that there isn't one already, either from a pre-existing IPv4 implementation of OSPF v2. The last step is the one in which in v2 you would create the routing process, you would give it a router ID, then you would start issuing network statements to add the appropriate networks on that device to the routing process. In v6 we don't do that. We don't actually bother typing all these prefixes and prefix lengths in. We do that actually by creating the routing process, then getting out of router configuration mode, going into interface configuration mode, and doing this: IPv6, OSPF, the process ID, and then the area ID. This is why it's so important to know what know on paper what your implementation should look like before you start this, so you don't accidentally put one of these things in the wrong area. So gig 00 area 0. 0000 area 0, 0001 area 0, and you can double check your work with a show command. Show IPv6 OSPF interfaces brief, and you'll see your interface ID, you'll see your process ID, you'll see your interface ID, your process ID, your area, your cost, and that you can look at that on the basis of what kind of interface it is and what its cost is, and you can make some guesses about what your reference bandwidth is. You can look at its state, you can look at how many neighbors it has, etc. This one has no neighbors, because I would assume this is the first router you've done this on. If you do the same thing on router 2, some neighbor adjacencies will form. You do the same thing on 3, the rest of your neighbor adjacencies will form. So let's look at verifying those neighbor adjacencies. And I got to move myself again. So you can do show IPv6 OSPF neighbor. You'll see your neighbor ID. You'll see a priority. In this case, we're talking about serial lines. Your priority is 0 because there's not going to be a DR-BDR election. You'll see your dead time. That is how much longer this neighbor adjacency will stay alive if another hello packet does not come in. As every new hello packet comes in, it refreshes this so it never reaches 0. You'll see your interface ID and the interface that it is using. And we've got a very helpful table to explain all of these things. So we can also, now that we've implemented, we're also starting to talk about verification. So let's talk about verifying the protocol settings. You can do that with show IPv6 protocols. So you see your routing protocol. You see it is OSPF10. You've got neighbor discovery going. You see your router ID. You see your interfaces and what area they're in. If you see one area, it's a internal backbone router. If you see more than one area, it's an area border router. Okay, so. And then let's talk about verifying the interfaces. We actually looked at this command a minute ago, but we'll talk about it some more. Move myself. Okay, you can use the show IP OSPF interface command to get a detailed readout of a specific interface. If you want to look at the broad picture, show IPv6 interface brief will give you everything at one go. I wouldn't use show IPv6 OSPF interface unless you're troubleshooting, say costing or neighbor adjacency or something like that. Some reason, don't look at that interface. Don't use the interface command because it will give you all of them. Or the best way to do this is show IPv6 OSPF interface, and then the name, the specification of that interface. If you do this command all by itself, show IPv6 OSPF interface, it'll give you the full readout on all of the interfaces which are using OSPFv3. The good news is it will do that, and it will immediately drop that into a scrolling readout that you can use. Basically, if you've been in a Linux class and you know what more and less do, whenever you do a show command and the output is longer than the screen, it basically pipes that to more, essentially. So we can also look at the OSPFv6 routing table. This is another tool I used in my kit when I was troubleshooting some of the mistakes I made typographically with the lab 8336. So this is our routing table. So show IPv6 route will give you the whole routing table. Show IPv6 route OSPF will give you just the OSPF routes. Notice that you don't have anything about a gateway on this output. Actually, technically speaking, you wouldn't. But even with standard OSP show IPv6 route, you can't shortcut and get over the code origin code block by doing show IPv6 route pipe begin gateway, because it doesn't work that way. There's a real good chance that the gateway is at the very bottom of the routing table. So you just do show IPv6 route or show IPv6 route OSPF. You can even, if you know which network you're trying to find a route to, if you want to look at its lookup, you can do show IPv6 route, and then you provide the prefix and the prefix length for the network you want to reach. Just like doing, say, show IPv6 IP route 192.168.1.0. You'll look at it, say, at the router and figure out, the router will tell you how it's going to try to get to 192.168.1.0. And let's see. And there is a packet tracer and a lab. And I guess I will summarize this now. So, in summary, and there's also a skills integration challenge. If you have trouble with the skills integration challenges, keep trying. Look back at the chapter. Look at your syntax checker exercise in Netacad. Look at the appropriate chapter of your portable command guide. Think about it. Don't blow off. Don't blow off. Don't leave explored the learning possibilities of these skills integration challenges, because you might not just have to do IPv4 and IPv6, OSPFv2, OSPF3. Maybe it wants you to do other things that you need to remember how to do, like NAT, ACLs, DHCP, layer 2 security. You never know what they're going to throw at you in these, and everything that they throw at you, you should expect to see in some form later on, whether it's in the final skills tests or a certification exam, etc. So, over the last few videos, I've been talking about how single area OSPF works. Its characteristics, the things that differentiate it from our distance vector routing protocols, what convergence means, how resource intensive it is, etc. We talked about OSPF v2, that is to say how to implement OSPF for IPv4. Creating the routing process, adding the networks, and then a little bit of tuning and troubleshooting with things like your reference bandwidth and your interface bandwidth, so you can tune the metrics that SPF will use as it's calculating its SPF tree to produce finally and ultimately the routing table. Then we talked about the same thing for OSPFv3. Creating the routing process, adding the interfaces to the areas, and so on and so forth. The good news is, for a lot of this stuff, the command syntax between v4 and v6 is practically identical. You could do the same thing. All the things you learn to do with v4, you can do with v6 by changing IP to IPv6, with the exception of the network command, which IPv6 does not use. As we mentioned, IPv6 adds interfaces, and this is actually exactly the way EIGRP does it, now that I think about it. Just as with EIGRP, you create the process, the AS, it forms its neighbor adjacencies, you add the networks to the routing statement, just like RIP does. But with EIGRP for IPv6, you don't do that. You create the routing process, you establish the potential for neighbor adjacency, then you go into the interfaces and add them there. OSPFv3 is the same way. Your router's identity and some of its basic settings, like passive interfaces and reference bandwidth and that kind of thing, is in routing configuration mode. The interfaces themselves are added to the areas in interface configuration mode. And that's all I've got for Chapter 8. I will be moving on to Chapter 9 and multi-area OSPF. Now, the thing to remember above all about multi-area OSPF is that multi-area OSPF is an accumulation of single area OSPF implementations. So if those single areas are not internally functional and correct, then the multi-area can't possibly be right. So get each individual area working and then worry about bolting them all together through your area border routers. But that's the next chapter. We'll move on to that next week. Thank you for watching and have a good day.